Division. Along with me is Jessica Bunker, also from WDTD. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from the National Weather Service in Paducah, Kentucky. Our presenters are Justin Gibbs and Alan Diegan, who will be giving a presentation titled Long Range Lead Time WoFs, Environmental Assessment, and Deep Supercells on March 14th, 2025. And with all that being said, Justin, the floor is yours, so go ahead and take it away.
All right, thanks, Chris, and thanks to everybody at WDTD for giving us a chance to tell the story. It was the first of several big events we've had this spring. So overall, during this event, we had 14 tornadoes impact our area. One of them was technically an EF4. We had EF3 damage in our area. It was a super long tracker, 5 EF3s, 5 EF2s, 3 EF1s. And fortunately, it didn't continue to produce as prodigiously as it moved across the eastern half of our CWA. We had 0 missed events. Every tornado, every segment had a warning on it, which is easier when the environment's obviously super favorable. It's part of a broader regional outbreak. Tornado moved to the northwestern part of St. Louis, had tornadoes in the eastern part of Springfield's area, northeastern part of Little Rock's area. They had a couple EF4s there with some pretty high-end damage near Diaz, Arkansas. Then it moved into northwestern parts of Memphis's area, which include the Missouri Boot Heel and northeast Arkansas. Longest track on the tornado was 118.95 miles, which is a very, very long track. I think our Beast tornado, December 10, 2021, the track on that was 158 miles. So we're in pretty rare air there. And then when we're exhausted and about to die, we had a supercell produced baseball-sized hail in Owensboro, Kentucky at 5 o'clock in the morning. The environmental setup, we had a sharp negatively tilted shortwave trough over Kansas and Missouri that created a very broadly diffluent flow. This is at 0Z. All the lift, all the everything responded as you'd expect. That's a pretty good spot for us typically for severe weather as far as the trough position. Low-level wind fields at 850 is probably a little difficult to see, but our 850 millibar jet analyzed on the RAOBS was 45 knots across a broad area there from Little Rock and Shreveport all the way into like Cincinnati, Wilmington, Ohio. And then the VWP was showing closer to 60 knots at 850 at one point. Little hand analysis there. The dark shaded green is 65-degree dew points, and the line to the north is 60-degree dew points, and all that was infecting into our target zone in the southeast Missouri. This was probably the most impressive environmental analysis of the event. The VWP at about 246Z, which is just before everything moved into our area. That's about as good a photograph as you could draw up. 0 to 1 kilometer storm relative helicity is 911 meters squared per second squared. Bulk wind difference 0 to 1 is 70 knots. And you can see that the one dot there is on the 70 knot line. So actually I misremembered. It's even stronger than that. We got about 1,500 joules per kilogram of mixed layer CAPE. We had a little bit of an EML steepening our lapse rates, but that was obviously overwhelmed and overcame with the strong low-level moisture advection. And the ML CAPE probably actually rose during the event to about 2,000 joules per kilogram, roughly, due to the strong low-level thermal advection and temperature advection. That yielded a significant tornado parameter of 10, which was analyzed in the meso-analysis. This is just before we started issuing tornado warnings, and our VWP was about 60% hotter with the storm relative helicity than this. So realistically, probably we were 10 to 12 on the STP. And December 10th, that historic tornado, we analyzed an STP post-event of 15. So we were closer to that than we were, a marginal, STP 1. It was an enormous environment, and we were able to recognize that in real time and sort of adjust accordingly by going, hey, we expected it to be bad. It was a moderate risk. And then it was one of those events where, okay, we're going to get everything that we wanted and then some. The convection allowing models, as they got in range, were very consistent, pretty much had the same take, a line of broken supercells, discrete cells. Some of the ensembles kind of highlighted the St. Louis area a little bit more. At the end of the day, the ensemble guidance and the sort of the machine learning stuff, you can see on the upper left, I guess it would be a version of machine learning, highlighted about 75 miles too far north of the actual probably gross target area at the end of the day, but the signal was still overwhelming. We had broken supercells in a favorable environment. All of them were generating sort of the helicity tracks. We've noticed sometimes when we get supers that aren't generating the helicity tracks, sometimes there's a little bit of trouble with the low-level thermodynamics. There hadn't really been any questions about the thermodynamics in this event. I think in the AFD, one of us wrote, running out of potential failure modes. It's hard to think of a way that this isn't going to go. And that was at like 4 p.m. and then the event happened that evening. And it was just like, it's hard to picture a way that this isn't going to be a big deal. The dew points, though, were the only thing. And Alan, if you want to interject a little about that, he was there in the early afternoon. The dew points sort of mixing into the 40s, and some of our EMs and stuff took note of that. And we had to reassure folks that the moisture's coming. So, Alan.
So on the partner webinar that we were giving for this event, a lot of our EMs took note of the super low dew points that we had. And I guess over the years, these partners will learn, typically we talk about dew points in the 60s, and they notice, oh, dew points in the 40s, that's not right. What do you think about that? So it's just interesting that they were, taking note of that and were asking about it. And just to give you an idea of how dry it was, we actually had a couple wildfires that popped up this afternoon, and we were providing DSS for these crews that were out there. And I know that at least two of these crews, that 2 of 3 tornadoes passed by, I think within a couple miles of where these crews were fighting the fires. So we were actively giving them phone calls, giving them heads up to get their crews out.
Yeah, absolutely. I remember about 9 o'clock, because they were fighting a fire that threatened property, and they're like, we want to fight it to the last possible second. They needed 15, 20 minutes, and we gave them a heads up, said, okay, it's time to get out of there. And they did.
Yeah, we had a 60 mile per hour gusts from the gradient wind. So pretty wild.
Yeah. Wildfire outbreak followed by tornado outbreak. For me, this is at 0052 Zulu, about 90 miles west of our area. We were getting significant tornadoes, and we had visual on them with the spotters. The chasers were doing their thing. We see these supercells with big nasty hooks and low-level velocity couplets producing tornadoes. The dew point at this point was 53, and then these cells were tracking into dew point air at 62 or 63. And I'm not the best meteorologist in the world, but it lets me know when we're getting significant tornadoes with a dew point of 53 tracking into a more favorable environment, that we're probably going to have a pretty long day. We were postured for that. We were full staff, all hands on deck. But that was the moment I went, uh-oh, we are in trouble. So about that point, we coordinated a watch. We advocated for, and SBC agreed that it was a particularly dangerous situation. And it turned out to be, with several tornadoes and a few intense tornadoes expected. Before the event, we had analyzed our environment, and this is the impact-based tornado warning guidance. It's been updated through the years as we get better at things. It talks about our catastrophic tag, tornado emergency tag, talks about the STP needing to be above 6 before you start to see that probability of EF4 tornadoes necessitating an emergency, and with 70 knot rotational velocity. And we had hit that. We were above 6. So we've done this a few times. We talked before the event, STP 10. So emergency's on the table. So when you get that couplet, we're not going to have to hesitate and go, is this an emergency? That freedom is there. We talk about the shift supervisor and stuff. They know the shift team or the radar team lead, which is kind of what we do, lets everybody know, hey, this is an emergency type event. We have a discussion about it when we make the decision, but it's brief because we've already went, okay, this is that kind of day, so let's get ready. And that's where we ended up. We established that before we went in. And then, Alan, I'll switch it back over to you, and you can talk a little bit about kind of what we were seeing in the WoFs.
All right, thanks, Justin. Yeah, I did want to give a shout out to the WoFs team real fast. They're incredible. They really helped us out on this night, really helping us with the watch the warning messaging. So we obviously knew that in the global models, a lot of the cams, that we had a pretty bad situation on our hands. Very violent environment. Question is, we saw the supercells out to the west in Springfield's area. Where exactly are they going to track? Are they going to hold up? Well, the WoFs tended to agree that they would. No reason why they wouldn't with this environment. Again, the WoFs team was in the chat. They were able to walk us through, and I'm not the best at, understanding like the machine learning probabilities and ensemble probabilities of this stuff, but they were there to walk us through that, show us what was most important. And then what I'm particularly proud of, and if you go to the next slide, is the timeline. So the watch was issued at 7:30. We had the WoFs team communicating with us, telling us everything that we need to know. Just really good confidence that this was going to be a very rough evening. So we initiated a phone call to our 4 western counties, Carter, Ripley, Wayne, and Butler, messaging the high danger of long track significant tornadoes. We did a similar process on December 10th, 2021. From there, Carter County, they broadcast this information to their fire sheriff's department, so they're able to get all of their assets together, and they broadcast it on their social media. So I believe there was a Fremont community Facebook page, I believe, and they put this information out on there. And over the next 2 hours, they would have 150 people gather in the Fremont Community Storm Shelter. Now, before we gave them a heads up and called Carter County officials said that they only had 4 to 5 people. And they credit this phone call to 150 people gathering before the tornadoes moved in. And, you know, Fremont's population is only at 43 people. So you definitely had people from outside of the Fremont community taking shelter there. Something else that we will also do, and typically when we have the higher confidence like this situation is, we'll send out special weather statements. So we did 2 this night. One of these was about 8:30. This was an hour after the watch. It's getting closer. Again, messaging the strong long track tornado potential, trying to give a heads up on when this activity would be moving into our SEMO counties. And then shortly after we were in warning ops, we did another one. I think Justin did this one. Again, messaging this potential is continuing and tried to give some ETAs for some downstream communities. And I believe, Justin, correct me if I'm wrong, but didn't we do the same type of situation for SPSs during the 2021 tornado?
Yeah, that was kind of where Chris, our recently retired first ballot Hall of Famer, Sue, he did that on December 10th. It's kind of in a similar role. Yeah.
Yeah, okay. Something else that we like to do here, if we can, is Facebook Lives. On this date, we did 5 of them, 3 of those in the afternoon and evening. These are really just, most of the time, these are pre-recorded videos, just a couple minutes saying, hey, here, heads up, this is what we're seeing, this is what we're expecting. And all of those Facebook Lives, we got upwards of 500,000 viewers. So we like to do this when we can. Again, staffing challenges sometimes doesn't allow that, but seems like our public, they like this, and just another way we can get information out to the public.
And I'll point out too, we use the OBS software on our laptops to make that work, and it really, really works well with Facebook.
Yeah, absolutely. Okay, now to some of the radar analysis. So just to give you all some perspective, I think I've had a little bit over a year as a lead forecaster now at Paducah, and before this event, I had issued only 2 tornado warnings in my career. And the last one was in 2021. So, you know, leading up to this, I knew it was going to be pretty bad. You don't really know sometimes you don't know what you're really getting into. And I made the decision, or I talked with some of the other leads, and I was like, you know what, I need some radar experience. And I got a lot of radar experience. So it's about 9:30. Supercell is coming out of Oregon County. This is Springfield's area. We knew we had long track tornadoes already ongoing. Environment downstream was great, prime. I did a time of arrival tool in AWIPS on this storm and had it hit in Fremont in about 30 minutes. I was thinking, well, you've heard sometimes there's too much lead time. What is that? Well, I mean, this is about as good an environment as you can get. You had tornadoes on the ground. The couplet was there. It was just really good storm. That area is very, you know, it's very rural. There's it's kind of hilly terrain, not a lot of cell coverage. It's like, well, 30 minutes is good enough for me. So that's when we issued the first considerable tag PDS warning. So it got closer. As soon as it moves into Carter County, Justin and I are looking at each other, looking back at the radar. Uh-oh, we got a problem. So we've got 4 different radars that we can look at in this area. Again, 4 radar coverage, but they're all you're looking at 10,000 feet or higher. I think Springfield may actually have a slightly better view with their new 0.2 degree slice, but this is from the Memphis radar, 117 nautical miles away, looking at 15,000 feet high. And I believe this is the 75 knot VROT from GR. And in ellipse, it was hitting 90 knots. I did look back at Springfield during this time, and it was also pushing 80, 85 knots of VROT. So what is the VROT relationship when you're that far out? I don't know. Maybe Justin can provide a little bit more information on this, but we didn't have a TDS, pretty far up, so can't really see that. But we did have confirmed tornado from spotters and law enforcement, emergency management. So that was enough for us. We issued the tornado emergency about 10 o'clock, I believe. Just a 15-minute warning just to get it through Carter County. Justin, I don't know if you have anything else you want to say on the VROT relationship there, but
just that it was uncertain. I mean, everything that we looked at, really says about 70, 80 nautical miles. It gets fuzzy, but I've never seen such a strong couplet at that sort of range. So it was like, well, we're going to go for it. And if we're wrong, we'll eat it. But it worked out.
Yeah.
And he had 3 damage,
When the guy that trained me on radar is telling me that we should go for it, yeah, I'm probably going to listen. But that was about as good as couplet as I've ever seen, especially at that height. Most of the time, when it gets to the edge of your CWA, you can hand it off to your neighboring CWA. You have the CWA, you don't have to worry about it anymore. Well, in Paducah, that's not always the case because we have a stair-step looking CWA. So it moved out of Carter County, moved into St. Louis's county warning area, and then did a meso handoff, and another mesocyclone developed and moved through extreme northwest Wayne County about 10:30. Did produce some damage in Wayne County, moved back into St. Louis's area, and then moved back into our CWA into Perry County, and would go on to produce a EF2 almost near the town center there in Perryville. So what resulted out of the Carter County storm? The first image there is before the tornado, and the second satellite image, you can clearly see the tornado scar there with the damage path. Most of this is very rural. There was substantial tree damage. I believe somebody on the damage surveys mentioned that some of the tree damage was getting close to the 2021 tornado out in the land between the lakes. Unfortunately, there was a few structures that were impacted. In this case, I believe this was a fairly new house that was just completely leveled. And there was a dad and son, and they actually took shelter in their gun safe and were able to make it out just fine. So, but that wasn't the only storm we had. Obviously, this was about the time we had the tornado emergency out. We had 2 additional couplets down there that I was having to keep an eye on. And then can't see it here, but further south, there was additional cells coming out of Arkansas that Justin would eventually have to keep an eye on. Because at this point, I had like 4 different supercells that I was watching. And again, I hadn't watched radar since 2021. I was stressed. But Justin, I'll let you, I think, take it from here.
So Alan's working kind of the extreme northwest. He's got what ended up being 5 EF3 tornadoes in his area that he was working. And I remember telling him, I was like, that felt really intense. And then we do the surveys and go, okay, we had the most EF3 tornadoes of any event in about 2 hours' time. I was working to the southeast. We had this meso here was the meso of the 118-mile long tracker. It was about to do a handoff. I had a tornado warning just south of the community of Poplar Bluff. And then it did a meso handoff. As you can see here, it hadn't really developed yet, but very rapidly developed, very deep and strong rotation. We went above 50 knot rotational velocity. At this point, we're about 70 to 90 miles from the radar. So I did a new tornado warning. I didn't wait and go, I said, okay, warning, we're going. And that's sort of how aggressive we were being in this environment. Our EMs, or our TV folks, get really confused in the 0.5% time that we do considerable tags without confirmed tornadoes. But I did do this and put it in the text. A large and extremely dangerous tornado was developing near Oxley, and that was based on the depth of the rotation, the STP-10 environment. and then put it in the chat that, hey, we don't have confirmation yet, but we expect we will get it. And then within about 12 minutes, we got a TD. I think we had a TDS on that, dude. It was a long way from the radar still, but we did have spotter confirmation, and we had EF3 damage right through the heart of Poplar Bluff, which is a town of about 16 to 25,000 people. So we wanted to give it the best warning that we could. Several success stories, people sheltered in the basement of this church in Fremont as well, in Carter County. Poplar Bluff residents got the advanced lead time and evacuated from their mobile home park that was completely obliterated into a nearby church where they were safe during the storm. Thankfully, they did that. We had a similar incident in Evansville, Indiana, in 2005, where 25 people died. So if they hadn't have evacuated, I suspect highly we would have had that kind of a death toll. We had one survivor in the park, and he went flying in his bathtub and told a pretty humorous story about going several hundred yards in his bathtub out of his mobile home. So, and then at the end of the day, end of the night, I think Alan went home about 1:30 or 2, and I said, well, I'll be out of here pretty quick. It's winding down. And then it wasn't winding down. We didn't get tornadoes, but we still had a very volatile environment. And this little guy with 70 dBz up to 30,000 feet shot up just west of the city of Owensboro, Kentucky, which has about 200,000 people in it. And I'm thinking, I might have to wake a lot of people up. I really don't. I better. And so we put this warning out about 15 to 20 minutes before, and they had widespread baseball-sized hail in the city of Owensboro. Probably did $200 or $300 million worth of damage. So I had to wake everybody up at 4:43 in the morning. They get hit with baseball-sized hail and get all their stuff tore up at 5 o'clock. And then at 11 o'clock, Kentucky basketball loses their game in the SEC tournament. So it was a tough day for Owensboro to deal with all that in one shot. And it's sort of our last slide here. Overall, Alan said we were very aggressive with our warning posture. We verified 21 out of 38 warnings. Most of that false alarm was over Western Kentucky. So we were warning. We took a guilty until proven innocent stance on all of our storms. We issued a few warnings along the Mississippi River, the Ohio River, like including, I think we warned on like Paducah proper, and those stopped producing. And it took us a minute to kind of figure out, okay, I think this is legitimate change in the environment. So we had about 10 tornado warnings. Well, actually, we had a few tornadoes in southwest Indiana still. So there was some favorability. It was just more EF1, EF2. So some of the false alarms came from Western Kentucky. And I don't really know I guess the low-level jet relaxed a little bit, and that made things slightly less favorable. But we had one supercell over Western Kentucky that I thought for sure was going to produce, and it didn't. We issued about 5 warnings on that over its track before we said, okay, I think this thing's dead. But we were proud of our EF3 average lead time damage was 25.8 minutes using those 45 to 60-minute warnings. It was one of the few days of my career where you walk out at the end of the day, and it was already apparent, like, man, we did something here, as far as safety, prevention of loss of life, where people saw what we did, had time to take cover, and survived in part because of what they did. So Alan did a fantastic job for his first time back, or even if he'd been doing it for 100 years. Chris, kind of the last event that he would work as our, well, no, he worked a couple more, but wrapped up on April 30th. But it was a fun event. As the fun that comes from working with a really good team and having things work out and knowing that you did some good, even though it was a bad day. So we were excited to share this story, and the work that the WoFs folks did is the first time we were able to go, man, the WoFs really helped us here. And I get it now, kind of how we can use this to do, we've got our formal radar-based tornado warnings, but we were also telling them, an hour and a half, 2 hours out, like, hey, we never know for sure where this is going, but everything we've got tells us it's going to be somewhere close to you, and it's going to be a big deal. So take cover, take the action you need to do it. So that's our story. And again, thanks for the opportunity to tell it. And unfortunately, we've had 2 or 3 more events that we probably can talk about since then. This event's kind of faded in the back. So I don't know if anybody has any questions or thing you want to chat about here. Me and Alan will be here. And Alan, if you have anything else you want to follow up on this slide or whatever.
No, just like you said, really proud of our crew here at Paducah. Every event we do well, but this one in particular, just you went home and you're like, man, that went really, really well. And just everything, communication, everything went very well.
Yeah, but the only downside was, like I said, I issued 4 or 5 tornado warnings in Western Kentucky that didn't produce. So any questions anybody has, we'll quit jabbering.
All right, thanks everyone for your attendance, especially for Justin and Alan for doing the presentation. Thanks for your time and attendance, and enjoy the rest of your day. We'll see everybody later.